Let me know if you can see my screen.
Yes, we can see your screen.
Okay, thank you. So yeah, again, thank you very much for your attendance. My name is Yudi Rahadian. I'm the AI product manager in Tebros. In today's events, I would like to explain about what is computer vision and how we can take benefit out of computer vision. So the what is computer vision? So computer vision is a subset of AI that will have a very huge impact and benefit, especially in industries like retail, healthcare, manufacturing, agriculture, and smart city. And sorry for the background. So we are, trying currently explore the beneficial of the computer vision because you can imagine that we're just using the object detection using camera or CCTV even. We can try to have a benefit from the image that currently is moving. For example, here I show you the how crowded is the transportation mass transportation in Japan or in China or somewhere in Asia, and you can also detect how many people are currently, and also you see here the bounding blocks between the peoples. You can also mitigate, or you can also see and find out either is a man, woman, and you can also classify which one is using suit, which one is using which one is not using suits, and so on. So this is the example of the computer vision. And why we need to have a computer vision? Because using computer vision, we can make a smarter decision in the real time, and we can create a new revenue opportunities with intelligent site anywhere. So as I said earlier, you can also try to explore and export the data generated by the computer vision, which later on you can utilize yourself and you can use for your own benefits. So later on, my colleague Okta will explain about the details how we manage to make a computer vision combined with deep learning. Yeah. And now I would like to explain about what the difference between computer vision when we deploy using cloud or edge. So what is cloud? When we deploy the computer vision using cloud, the device send the visual data into the cloud. Either you can see that the AWS, Google, or Azure from Microsoft. And then meanings that you have to have like a big panel and with a big data, send it through over the internet, right? So let's say your server located in one city and the computer vision located in another city. So you can imagine the transport between them, and it will always become a backlog. So that's why it can lead very big latency in between, so it will not very fit for computer vision use cases. Therefore, come idea to have a edge computing. So edge computing is more having like advantage over the cloud in terms of reachability, speed, and also privacy. And the most important is the cost. If you try to send the data using cloud computing, of course you can consume a lot of how to say a lot of money, because you are trying to not only send the data through the internet, which can cost a lot of money, but also you need to have a big, huge storage in the cloud side. So therefore, it's not recommended that you are using cloud computing for computer vision use cases. And the edge itself, you provide everything on the edge next to the computer vision use cases, because like this you can save more storage, you can save more infrastructure, and also you can save more latency between the use cases and the server. So the function of the edge computing is you capture the visual data using any kind of camera, and then directly you do computation locally in the device. So you're closer to the source of data, and the action we can be also directly provided on site. So that's why it will be more like real time, or even near to real time, that the data can be utilized for your own businesses. So you don't need to have like very big delay when you try to send from the use cases into the cloud. So we prefer to have edge computing using the computer vision use cases. And why computer vision require edge computing? First, the response times is almost to zero, to minimal latency. Yeah, so meanings that similar like you put your own laptop and then you directly put into your own webcam and then you can process it like real time. So the bounding box and also the data analytic and also the local storage will be very saving cost and also very how to say very fast response between the server in back end and also the front end. Yeah, and the second is more secure. Why I call it more secure? When you try to send your data into the public internet and then to your own cloud, there is possibility that in the journey when the data is transported from the use cases from the devices to the cloud, there will be something like bugs or something like hacking or something like leaking on the data itself. We never know because it's beyond our knowledge if we put our data into internet, right? But with the edge computing, you localize your own data, which also maybe belong to your customer, right? And like this, you can try to save it, make a sandbox, let's say, and try to save it the data in the computer, in the small computer between the use cases and also the cloud. So this is localized. I mean, if you are localized on premises, everything means that it's more secure, right? And the third one, of course, is more um, cheaper than you compare to the cloud computing. So in terms of lower cost like setup, inference, data inference, and deployment as well. So everything is on the side. So why I call it is lower cost associated with setup because everything is just plug and play. You don't need to have something like extra configuration in the cloud, like making elastic computing, let's say, in the cloud, but the computer itself located in the site. And the computer is not like what you imagine, like the laptop, or probably you imagine like a small SBC, but the computer itself, you can associate it with Raspberry Pi, Jetson Nano, or even Intel Vino. So this can be mitigated less than $100 or €100. So it's really cheap related to the setup. And to the inference itself is really cheap because if you try to use features available in the cloud, like Greengrass, like another from AWS and another resource, it will cost you a lot of money because you know to train the model and to collect the data set, it will meanings that the cloud itself you have to pay per hit, yeah, or maybe per use. So it's depend. But if you are using your own edge computing, you can even inference your own data. You can train your own data locally, directly in the uh, edge on the local computer, let's say. And then there you can also try to always continuously train your data and continuously deploy your data. So like this, you save more money and more spaces, of course. Yeah. So that's the benefit of edge computing. Now I will go to the use cases. So I will start with the retail use cases here. So you see here there is like cashier. They try to also make some analytic here with the bounding box and so on. So they would like to identify their purchase patterns. So let's say there is one guy here, and you can see that it's not, we are not only targeting to the guy, you know, like we also seeing that how many purchases that they buy. So of course this need to be in a more improvement because we need to always train. So we are not stopping here, this is only for showcases. So you always have to see and check whether that the target of your use case of your business is according to your customer requirement. So like this, because of this decision, it's not only to show to the camera or to the CCTV, but the numbers here we can use as a data analytics. Let's say the retail use case example is Amazon Go. You just come into the stores and then you just take whatever you need, and then directly they will charge it from your credit card, right? So that's what of the example use cases of retails. So the retailers can take informed decision about product placement, store layout, and staffing. Yeah, so it's very interesting. And I will go to the next. The next one is manufacturer uses cases. So with machine vision, also you can monitor the working employee to improve productivity and efficiency of each workers. It doesn't mean that you monitor all the manufacturer workers as that they're working or not, but it's only to make sure that um, the efficiency and the effectivity how they work. So let's say they work for 8 hours a day with break 1 hour. So like this, you can see always as a owner, as the factory owner, let's say you want to um, understand how productive are your workers, and either you need to add additional workers because you think that, let's say here in the bounding box there is like how many people, 1 2 3 4 5 6 8 people, 9 people around about. Are there enough to do your works, and are you satisfied with your product result? And also how can they increase their productivity. So you can say that, hey, okay, you work very well, but you see that there is something need that you to improve. Normally in the factories they have some supervisor who checking one by one, right? So they are checking back and forth. They take a walk and see if everything is according to the SOP or the MOP of the factories. But with this computer vision, you don't need to check one by one. You can see that there is also numbers here, the green one and the red one. You can see how productive they are, and are they are doing the according to the MOP and SOP of the factories owner set. So of course, beside this, probably you guys have some idea about how to improve the manufacture use cases. Then you can also develop your own, and then you can have like insight for your customer that the manufacturer use cases, there is a lot of things to explore. Yeah. And the next one is agriculture use cases. So for agricultural use cases, we are using cattle's weight and calving monitoring to monitor the growth of the cattle and predict the calving period of cattle. Why? Because this is very important for the farmers. Let's say now they need to check and measure manually, right? One by one. So imagine you have like a big farm, or maybe you have a small farm with 100 cattle or 100 cows, and the time you have to spend to measure one cow, let's say 5 minutes or 10 minutes, more or less. So it will always cost a lot of consume a lot of time, effort, and of course money. With computer vision, we can just check according to our research that you can see here the cow itself is 100 kilos or more. Yeah, so maybe it's not accurate, maybe the accuracy, let's say 80% to even 70%, right? But we just need to have like continuous improvement, because we will always monitor this cow, and then from there we have a reference for us to learn the data, so the data can be clean, and there is no like dirty data set, right? So this is what I mean. The agriculture use cases is very sexy for computer vision because there is needs also, but less supply. And also you can predict the calving period of cattle. So based on, we are not the expert of agriculture or cow and so on, we are only providing the technology. So based on their research, we can also always try to cope and adopt it. Let's say the cow, here you can see that they are sitting and they are not doing nothing. So there is also possibility that now they are in the calving period, right? Or probably they are not feeling very well, who knows? But from our computer vision, we can also predict, right? So we have like analytic, later on we can use as a decision making also. So this cow is sick and we need to call veterinarian instead, or probably he just like to do how to say, estrus with another cow. So, and you don't need to be on site, you just can be somewhere else, but you still have the visibility to see what is problem with your farming. Yeah. Okay. Yeah. So for that, I would like to introduce you our new product called HAI. So this HAI means that you can always try to rely on your AI development, whatever is said, like can be retail, can be agriculture, can be many things, manufacture and so on. So for that, we provide you the ready to use plug and play. You can put our HAI computing into your AI use case computer vision deployment. So it's very easy. We already provide you some models. Let's say you have manufacture, you have agriculture, and so on. We'll provide you a pre-trained model, or you can upload your own models. It's depend on how you like, right? So like this is will be easier for you. You don't need to think about the pipe. You don't need to think how to make a computer vision or make a edge computing so we can able to save money and so on. So you don't need to think about it. You just need to focus on the AI use case itself. And the second is you can also use our customizable API to quickly enable your computer vision services, meaning that we have already open API for you to use, and then there you can also deploy your own, or you can also ask to support your project. That's will be on your decision. And the last one is using your own edge device, you can easily test and prototype. This is very important, especially for your customer, because they don't want to delay the time to just spend extra money to something that you need to develop from scratch. So you don't need to reinvent the wheel. Your customer will be also happy, because like this you can always show to them, make a showcase like, look, this is what I mean. I already perform your quick prototyping, and then this is will be the result. So like this you can engage more with your customer, and of course your customer will be happy and willing to pay more, because it's much more faster than they expected. Yeah. So yeah, if you are interested with our solution, please send us email, or you can visit our LinkedIn page, or you can also visit our website. So thank you very much. Now I give the presentation to Hans. Thank you, Hans.
Thank you, Mr. Yudi Rahadian, for the insightful
Yeah.
opening presentation. Now, I would like to welcome Mr. Okta Fajar Suryani to deliver the presentation. The stage is yours.
Uh, okay. Hello all. My name is Okta Fajar Suryadi, and currently I am working in TechPros as a AI engineer. And now I'm focusing my AI development in the computer vision for the smart agriculture and smart city solution. Let me share my screen. Oh, oh wait. Okay. Wait a minute. Maybe. Okay. Can you see my presentation?
Yes.
In the previous session, Mr. Yudi Rahadian already talk about the user story about uh, computer vision application in our daily life, right? So here I want to talk more about computer vision itself. What is the workflow for building the computer vision apps, and what is the challenge we usually meet when building the computer vision app. And also I want to talk about uh, uh, deep dive to computer vision example, and I will explain to you about how we can build a system like that. Okay, let's go to first uh, first my first point. Here I will talk about the computer vision using deep learning approach workflow. There are, if you see in this slide, there are four steps in the computer vision workflow. The first one is dataset gathering, and then dataset annotating, and then model training and evaluation, and the last one is model deployment and optimization uh, into a specific hardware. I will explain it one by one. So in the dataset gathering, if you want to build the computer vision apps or computer vision solution, first of all, you need to determine your task, and your task is representing what is dataset will you use. For example, in here there are so many open source platform that provide us the generic dataset that we can use. For example, there are Kaggle and ImageNet platform. Uh, Absolutely. Actually, in the Kaggle, you can find so many dataset, not only for computer vision, but for other tasks like natural language processing or time series analysis and other. And in the ImageNet, you can using the ImageNet dataset to create computer vision apps like object classification, object detection, object segmentation, and so many other computer vision apps. Okay, that's about data gathering, and then in the second step, there are dataset annotating. Uh, Here, why we need to annotate our dataset. Uh, if we talk about the supervised learning approach, so in the deep learning approach, there are supervised, self-supervised, and unsupervised. But if you talk about supervised learning, you need not only dataset but also the label or ground truth of the dataset itself. And then the ground truth or the label of your dataset will be used by model uh, to try to find the rule that represent your dataset. So in the supervised approach, the label or ground truth is very important. And then in the next step, you after you get your dataset, after you get your label or ground truth, you can start training your model and evaluate it. So nowadays there are so many deep learning framework that already provide us with the ready to use deep learning operation. So we don't need to create the operation or implement the operation from scratch. We can use, for example, there are two others. There are two major most popular deep learning framework. They are PyTorch from Facebook and TensorFlow from Google. So you can train and evaluate your model using this framework, deep learning framework. And then for the last approach, there is model deployment and optimization into a specific hardware. Why optimization is important? So uh, Mr. Yudhira Ardian already said that nowadays deep learning deployment tend to use the edge AI device, right? And we know that edge AI device is identical with the not high-end device. Edge AI device has the very limited computation resource, right? Right. So if we can optimize our model based on the hardware where our model will be deployed, it is automatically can give us so many benefit. For example, if we can optimize our model, we can get the faster inference time, like that. So here for the optimization technique, there are three most popular libraries from there are TensorRT from NVIDIA and TensorFlow from TensorFlow Lite from TensorFlow Google, and then OpenVINO for Intel devices. uh, TensorRT, because it is from NVIDIA, it is very suitable in the uh, NVIDIA hardware. For example, we can use Jetson Nano, Jetson Sapphire for our edge AI device, and then TensorFlow Lite is very suitable with uh, for the general embedded device like Raspberry Pi or other uh, general embedded device, and OpenVINO is suitable for the Intel devices. Okay, this is computer vision workflow, and then I want to talk about computer vision challenge. So usually, uh, if you have a specific use case, or if you have a use case from your customer, and accidentally there are no data set provided by Kaggle or ImageNet. So here it is clear that you should create your own data set, right? Because there's no data set that you want to use in Kaggle and ImageNet and other open source platform. Okay, so you should create your own data set, and uh, in in order to create a custom data set, we should consider some points. For example, our dataset format must meet the model requirement. For example, uh, in the in the object detection task, you can use the object detection model like YOLO or faster RCNN or other. And this model YOLO, faster RCNN, like need the dataset in format bounding box, right? So you should follow the format that required by your model. And then the second point is you should uh, make sure that your dataset is balanced. So you should consider how to design the dataset gathering process, so your dataset can be balanced, and you can avoid the imbalanced dataset, which is a very crucial issue in dataset gathering. Imbalanced dataset, because if your dataset is imbalanced, not balanced, it will affect your model performance very much. And then of course, if you because you collect or gather your dataset, your own dataset, so you should create the tools for annotating your dataset, right? So you should create the tools for dataset annotating, and the tools uh, should be achieve output that similar with the model requirement. And I think for the other process like model training, evaluation, and model deployment and optimization, I think it is not so difficult, because the tools like PyTorch, TensorFlow, and the others, and the libraries itself is well maintained by well reputation organization, Facebook, Google, NVIDIA. Uh, we can say that all the organization is well maintained their libraries and have well reputation. Okay, and then let's talk about specific example of computer vision solution in smart agriculture. Okay, please see this picture. Uh, if you look at this picture, uh, actually this is what we are currently developing in TechBros, and now we still trying to make it a proven concept that can be implemented. And the most important thing is uh, we we are very uh, careful, and we should make sure that our solution really help the breeder to make uh, manage and increase their revenue. So using the computer vision, we are proposing so one, two, three, four, five feature. So only using RFID and camera, here we are using two-dimensional camera and three-dimensional camera. We can we hope we can achieve food consumption, and then body score classification, lameness detection, heat detection, and early mastitis detection. And then the system configuration is like in picture here. To achieve the food consumption estimation, we are using the 3D camera. So the 3D camera can read how much uh, how much uh, consumption of coals each time or maybe each day. And then using the two-dimensional camera in the side of the in the side of the coal, we hope we can perform some solution like body score classification, and then weight estimation, early mastitis detection, and lameness detection. So this is our proposed solution. And you already know the high level concept about what we want to achieve, and this is I want to explain about how the data and how the prediction is made inside our system. So like Mr. Yudi said before, we are using the Edge AI device. Here we can use the Jetson Nano, Jetson Sapphire, or maybe Raspberry Pi. So the camera will so the co-data or co-picture will be captured by camera, right? And then the camera will send the picture into HAI, and then inside the HAI there are so many model running. Uh, uh, for example, food consumption, weight estimation, and then from the HAI we store the information like food consumption, weight, and then body score of the cow into the database. In here, database is located in cloud, maybe using AWS or Google Cloud Platform. And then each picture that are received by HAI, HAI will perform two things. First, it will predict the the output, and then send the picture into uh, how to say into more high-end devices to train our model. So there is a model updater, so our model can so we can improve the performance of our model iteratively. And then in here we have two schema. The first is live access, which is from the camera, and then HAI perform prediction and then send the prediction result into the end user, or the end user, if end user want to know the historical data, end user can access the database, and then the database will give the end user the historical information like this. So this is the front end, our proposed our front end idea, where for the live access there there will be live streaming from camera, and then uh, uh, the result weight, how much cattle weigh, and then body score condition. For example, if the score is 4, and then there is a description that describe what is the meaning of score 4, and then food consumption, how much cattle food consumption in this day on in this time, like this. And then for the report or historical data, there will be like this, so we can monitor the weight and food consumption and body score condition of our cattle. And then if we can read the historical data, so we can uh, provide some action if there is some disease, detect some disease based on this data. So it is very useful. We can perform early disease identification. Okay, and then this is showcase. I will show you the result of cattle uh, counter and cattle weight estimation like this. Okay, you can see that using computer vision, we can get the number of cows in the screen, and then we can get the weight of the cow that appear in our screen. Okay, uh, let me continue. Uh, Now I will talk about the some specific example of computer vision solution for smart city. Uh, as we know, um, currently there are so many CCTV cameras that installed in highway, right? But the CCTV is not utilized to doing anything more, right? Uh, Actually, using AI and deep learning, uh, we can uh, we can uh, inject the intelligence inside this camera, and we can make this camera to perform some amazing things. For example, using the already installed CCTV on highway, we can perform the traffic flow prediction, license plate recognition, vehicle counter, and motorbike detection when entering the sidewalk. If we combine the traffic flow prediction and vehicle counter, we can provide useful information uh, for customer or for citizen, so it will help them to avoid the traffic jam, right? And then for the if we combine the motorbike detection when entering the sidewalk and license plate recognition, we can help the police to perform automatic automatic traffic violation ticket, right? So the police will the police tasks will be easier because we can help them using the AI. Okay, and then I will show you about the vehicle counter and motorbike detection when entering the sidewalk and traffic flow prediction. Okay, the first one is this. Uh, okay, I will fast forward. Okay, for example, we can detect the motorcycle that enter the sidewalk. It is very dangerous uh, for walker, right? So for biker or for walker, it is very dangerous if there are some motorcycle that enter the sidewalk. So it will help us to uh, identify, and then if we combine with the license plate recognition, we can automatically scan the license plate of this vehicle, and then we can report to police or government. Okay, and if the uh, not only can detect the motorcycle that enter the sidewalk, this solution can also count the number of vehicle based on its type. So it is very useful for to help the government for how to say uh, for manage the traffic, so the citizen can avoid the traffic jam. And how it works, so this is the detection result by CCTV using the object detector. It is the result is object detection like this, and then how we can uh, how we how we can determine that the vehicle entering the sidewalk or not. So we can draw the polygon that represent the road, and then when there is or there are vehicle that uh, in the outside in the outside of this polygon, it will be considered as entering the sidewalk like this. So the bounding box is red, so it is represent the alert or violation is detected. Okay, and then this is the example of traffic flow prediction. Here, this is uh, uh, the the AI apps will be counting the number of vehicle based on its type. For example, car, motorbike, bus, truck, uh, or other vehicle type. And then from the counting result, it will be used to predict the trend of the traffic at that day or at that time. And this is the diagram. So this is the detection result by CCTV, and then we can save the counting result in database, and then using the counting result that's stored in database to fed in our deep learning recurrent model, and then using the deep recurrent model, we can predict the trend of traffic flow. And if we combine, we can see the dashboard like this. Okay, maybe that's all from me. Thank you for your attention, and thank you for attending our event. Thank you very much.
Thank you, Mr. Okta, for your invaluable insight. I hope everyone can understand and gain valuable knowledge from both of our speakers today on how to transform your business with deep learning and computer vision. Now, we would like to open the session for question and answer. Please feel free to ask questions to our speakers. You can type in the chat box or turn on your mic. Please feel free to ask. Do you have any thoughts about the AI computing? Or Mr. Yuji Rahadian and Mr. Okta, do you have anything to add?
No, I think yes, we cover all. Thank you very much, Nizam and Dominic, for coming. So I guess that we can conclude our webinar today, and I really appreciate that you're coming today. I hope that it can be also beneficial for you guys about the HAI. And yeah, thank you and have a nice weekend. Yeah,
Thank you.
thank you. Bye bye. Yeah,
Thank you.
you're welcome, Dominic. Thank you.
Thank you. Bye bye.
Bye bye.
Okay, thank you.